Okay, let us start connectedness. Connectedness in RN. Okay. So first we give some introduction about the connectedness. We say that a metric space or a space is connected if it is a single piece. So a metric space or space is said to be connected if it is a single piece. See, this is roughly speaking. This is a very difficult notation to be formulated precisely, and if we look at just r minus 0, we would think of it consisting of two pieces. And here we draw a picture, that is r 0, just to remove the point. So r minus 0, that is equals to minus infinity 0 open 0 to infinity. So if you look at r minus 0, we would think of it consisting of two pieces, and namely one piece, that is one is of positive numbers, that is r plus, and the other of negative numbers, that is r minus. Similarly, if we consider an ellipse or a parabola, just to consider an ellipse or parabola, and it is in a single piece. So ellipse and parabola, they are in single piece. But while you consider a hyperbola, or rectangular hyperbola, it has two distinct pieces, and next, if we remove a single point from a circle, it still remains as a single piece. So you consider a circle and you remove a point, so that is looks like this, and that is also still remains as a single piece. So we start with a definition which is unintuitive, but with examples and further exploration, see that it captures our intuitive ideas. So what is actually done here? Now first thing is, just when you think a connected set in Rn or in any space, so you just consider it a single piece. And for disconnected set, it may contain two or more than two, it may be three, it may be four, or more than four or more than two connected components. So what is the basic definition of the connectedness? Now when if is saying roughly, it looks like a single piece, that is very important. But the mathematical definition in mathematics, a metric space or a space X is said to be connected if the only sets which are both open and closed in X are the empty set and the full space X. So just I write the definition for connected set, and that is the basic definition. A space or metric space capital X is said to be connected if the only sets which are both open as well as closed, that means closed sets in X, that is very very important. In X are the empty set phi and the whole set X. And if you think the subset, a subset capital A of a metric space or space capital X is said to be connected if A is a connected space when considered as a metric space or space with the induced or subspace topology. With the induced or subspace topology. So just let us see an example. R is connected while R star, that is set of real number minus 0 element, that means the subset of non-zero real numbers, is not connected. If you consider Rn, so Rn again belongs to natural number, that means R, R2, R3 all are connected set. And that is holds for all n belongs to natural number. Okay. So here we recall some basic facts. The fact is the X is called disconnected if and only if it is not connected. That means if and only there exists two disjoint proper non-empty closed sets, that means closed as well as open closed sets A and B such that X equals to A union B. In such case, the pair A comma B, that pair is called separation or disconnection of X. That means the pair AB is called separation of X if the following property holds, that is A and that is B. So the relation is first, A and B both are open. Second, A and B both are closed, that means both are open sets. Second, and third is they are disjoint, that means the intersection B equals to phi. Fourth property, they are proper. Fifth property, they are non-empty. And sixth property, X equals to A union B. So if all this property holds, then A and B are called separation of X. And if the separation exists, then X is called disconnected. The definition is very, very important. And here one example, one recall is very much important for any space. Let X be a set such that it contains at least two elements, that is cardinal number of X greater than or equals to 2 with discrete metric. Then X is connected set. X is connected set. Next. Not X is not connected set. Not connected set in X. Say just you consider in Rn, and n belongs to natural number, and you take a set S with two elements, at least two elements. Say X with cardinal number of X greater than 2, and you define a metric, discrete metric. So S comma D. So obviously that set is the metric is discrete metric. Then obviously S is disconnected. Because if the metric is discrete metric, so you take S equals to, A1, A2 and A1 to different points. You take A equals to singleton set A1, B equals to singleton set A2, and both are open as well as closed. Also intersection B equals to phi and A union B equals to S. So A and B are the separation, that pair is the separation of X, and hence S is disconnected. So that is very important result, and that is also important for NET exam. In some question which is come in NET exam, there are same type of problem, okay, and that's why it is important. Okay, so my first question is here to all of you. When is a finite subset of a metric space is connected? When is a finite subset of a metric space connected? Okay, that is my question to all of you, and it is the left in exercise. Okay, left in exercise. So in Rn, any interval, the interval may be closed, may be semi-closed or semi-open or open. Obviously subset of R is always connected set. And the second result is any singleton set A belongs to R is connected set. The third case, R minus A, what is A? A is any real number, that set is disconnected. And the metric space, where R is a metric space, that metric space is called the usual metric space. And here the matrix D is defined, dxy equals to modulus of x minus y. Okay. So my question is here, another question, if we consider R2 and if we omit some point from R2, that means you take a point A, that is A1, A2, the point A, and you subtract this point from R2, that singleton set. Is it connected? Okay. So when we subtract a point from R, the set of real numbers, it is not connected. But if we subtract a point, not only a point, you will subtract finite number of points. That means that is our R2, and you subtract all those points from R2, that still remains connected set. So what is the basic facts here? And that question for all of you, why if we subtract a point from R, it is not connected, but if we subtract a point or finite number of points from R2, R3 and R4, and it remains connected. That is the question to all of you. So, under what condition, if we say just you subtract from Rn to any set, say A, and with the condition on A, which condition if we apply, for which it remains connected, and for this purpose it is disconnected. So just think about A. That is valid and still important question for CSIR net exam. What are the dimension of A? And which dimension if we remove from the set Rn, and it will remains connected, and or it is disconnected? That is a good question. So you think about it, and in our next class you must see what is the logic, which set we subtract and for which condition it remains connected or not connected set. Okay, so that is also question. Okay, so you just try it, and in the next class obviously we give the answer. What are the conditions behind, what is the reason behind it. Okay, so here we also recall some other definition. A topological space, capital X is connected if and only if every continuous function if x2 plus minus 1, not only here we take plus minus 1, you take plus minus 2, you take plus minus 3, you take two different points also. Every constant function f x2 plus minus 1 is continuous function, f x2 plus minus 1 is constant function. And obviously a subset A of X endowed with subspace topology is connected if and only if every continuous function, the same result is also holds here, every continuous function if x2 plus minus 1 is constant function. That means if there exists a continuous function f x2 plus minus 1 which is not constant, then the space is disconnected. So we are talking about the negation of this definition. So if there exists a continuous function if x2 plus minus 1 which is not constant, then we say that the space X is disconnected. Disconnected set. Okay. So now we think about the connected set in R. Okay, a subset S, subset of Rn is called disconnected if it has a separation a separation u and v. And if that does not exist any separation, so S is called connected set. And another recall, if a subset of Rn is connected set and if a to Rn, that function is continuous, then f of a, that is also connected. That means continuous image of a connected set is connected, and that result is very, very important. And another recall, let ai, what is I being index set, I being an index set, be a collection of connected set in Rn such that ai intersection aj, that is not equals to phi for all I not equals to j, then a equals to union of ai, I belongs to that set is connected. Next, let recall, let A be countable subset of Rn, then for all n greater than 1, Rn minus a, that is connected. Another recall, let x and y be any two connected set in a matrix space or space, then the product space, I think all of you know product space, x Cartesian product y, that is connected. Okay. So that are the important recall for the connected set in Rn, and here Rn basically the domain of a function in several variables. And for this purpose, that is also related to matrix space and topological space, but here we only focus on the function of several variable, the domain on function of several variable. That means topology on Rn. So now we are giving, we basically solve some important examples, which is very much important in our exam, especially in NET, TIFR and NVHM. So which of the following set are connected? Person, option 1, all those xy belongs to R2 such that x square plus y square equals to 1. Option V, all those xy belongs to R2 such that xy not equals to 0. Option C, all those xy belongs to R2 such that x square minus y square equals to 1. And option D, all those xy belongs to R2 such that x belongs to Q and y does not belongs to Q. A very good question in any other exam. It also important for NVHM and NET exam especially. And our answer is here. The first, for the option A, just you draw the graph in R2, and that is x square plus y square equals to 1. Just you think about our roughly speaking concept. A set is called connected if it is a single piece. So I think when you see the graph of x square plus y square equals to 1, that means the graph of the circle with center at origin and radius 1, it is basically a single piece. Obviously that set is connected. And the main thing is not only in R2, if that is given x, y, z belongs to R3 and x square plus y square plus z square equals to 1, that means a sphere in 3-dimensional space, that is also remain connected because it is a single piece. So if you draw the graph, and from graph you automatically say it is single piece or not, it has only one component or more than one component, connected component obviously. If the connected component is only one, then that set is connected, and if the connected component is more than 2 or more than 2, then obviously it is disconnected. So obviously that is the connected set. Okay, you think by another corollary or another type of facts. So in any fact you can conclude the circle is connected in R2. Okay, well, that set is connected set. Connected set. Okay. Next thing is for option B. For option A is correct. For option B, just you think xy not equals to 0. So you draw just a graph R2, and here xy not equals to 0. That means x not equals to 0. And both x and y not equals to 0.